Okay, this is our e-learning snow day makeup lesson. We are going to be reviewing simplifying radicals and working with radicals because, as you've probably already seen at this point, we are going to be using them in this unit, and so we need a little bit of review. What we will start off reviewing is just how to simplify a square root. Some of you might remember this much better than others, and if you feel like you're comfortable with this, then jump right to the assignment. This is completely at your own pace, so watch as much or as little as you think you need to, but understand that you're responsible for this material. What we are going to start with, like I said, it's just simplifying the square root. So what we are going to do is break down the number into its prime factors until we get a pair that we can pull out. So 75 breaks down to 25 and 3. Anywhere I see a prime number, I will circle, knowing I'm done with that part of the tree. 25 then breaks down to 5 and 5. So think about this. The reason why we're pulling out pairs. This 75 is the same as 5 times 3. That 5 times 5 is 25, which is a perfect square. So when I take the square root of that, that is why there is only one of the pair that comes out front. Whatever does not have a pair stays underneath. For number 2, 80 breaks down to 8 and 10. 10 is 5 and 2. 8 is 4 and 2, and then 4 is 2 and 2. So I have pair of 2's here, one comes out. I have a pair of 2's there, another comes out. The 5 is left underneath. Anytime you pull more than one number out, you are going to multiply those. So this is 4 radical 5. If we look to variables, I'm still looking for pairs. So think about how many pairs of m's can I make out of 6? Well, in 6 m's, I can make 3 pairs, so I'll take all 6 out with none being left over. Of 1n, I cannot make any pairs, so the 1n will stay under the radical. For number 4, work with the numerator and the denominator separately. So on top of 5 x's, I can make 2 pairs. That would be 4. With 1 left over. On the bottom of 9 y's, I can make 4 pairs. That would be 8 with 1 left over. All right, looking at multiplying and dividing. On number 1, we have radical 8 times radical 14. You can multiply the 8 and 14 underneath. That would be 112, so this is the same as radical 112, and then you would simplify that to 2 radical 28. If you feel like you don't know how to simplify radicals, you need to be stopping the video and simplifying these on your own for the extra practice. For those of us that don't need that, I'm just going to give you what it simplifies to. Again, understand it's your job and your responsibility to know this material. On number 2, again, these are both under the radical, so I can write this under 1 radical and divide the 162 by 3, which is 54. We would simplify that, which simplifies to 3 radical 6. On number 3, I'm going to distribute the radical 3. Now, notice the 6 does not have a radical. This is just going to be 6 radical 3, but when the 3 and the 6 both have a radical, I will multiply those under the radical. So this is 6 radical 3 times radical 18. I will simplify the radical 18. Oops, that's a 3. I will simplify the radical 18 to 3 radical 2. Now, when we add or subtract, we cannot do it unless it has the same number under the radical. So I cannot combine those two. I just have to leave it like that. On number 4, we have 2 radical 3 quantities squared. We've done this a little bit in the first lesson this unit, but we'll take that exponent, distribute it to the 2, so 2 squared times radical 3 squared. That exponent goes to both parts. 2 squared is 4, radical 3 quantity squared is 3. We multiply those, 12. Number 5, we have 2 binomials. We have to FOIL. We have to distribute the 2. We have to distribute the radical 2. So let's multiply. 2 times 3 is 6. 2 times radical 5 is 2 radical 5. Negative radical 2 times 3 is negative 3 radical 2. Negative radical 2 times radical 5 is negative radical 10. Anytime they're both under radical, you can multiply them. When we add or subtract, again, we can only add or subtract when we have the same number under the radical. Same number under the radical when we add or subtract. So if you look at number 1, right now we can't add these two because one has a 12 underneath, one has a 3. But if you were to simplify radical 12, it goes to 4 and 3, so this simplifies to 2 radical 3. Once it's simplified, then they have the same number under the radical, then we can add these to 5 radical 3. Same thing with number 2. 27 and 3 are not the same, but if we simplify radical 27, the radical 27 simplifies to 3 radical 3, but don't forget that coefficient that we already have. We would multiply that to be 9 radical 3, bring down the negative 5 radical 3, and then you could subtract. The very last thing that we need to look at is what we call rationalizing the denominator. We'll need this for later on this unit. It's not considered simplified if you have a radical in the denominator. So what we need to do is multiply top and bottom by whatever that denominator is. Because if you think about multiplying now, radical 5 times radical 5 is just a plain 5. That cancels out the radicals. On top, we would have 2 radical 5. It's okay to have it on top, just not on the bottom. The last one, again, multiply top and bottom by whatever's on the bottom. So 3 radical 2 over 2.